Analysis of plane frame. An example for analyzing a plane frame is selected to illustrate some features of ELPLA for analyzing frames. Geometry of the frame and loads are shown. All frame members have cross-section dimensions of 0.2 meter by 0.5 meter. Young's modulus of the frame materials is 2 by 10 power 7 kilonewton per meter square. It's required to analyze the plane frame. This tutorial manual will not present the theoretical background of modeling the problem. For more information concerning the method of analysis, a complete reference for numerical calculation methods are well documented in the user's guides of ELPLA. After opening the program, from file list here, we will start a new project. After that, we have the calculation method wizard. So we will select the analysis type and it will be analysis of plane frame. Then next, and from system symmetry form, we will select unsymmetrical system. Then next, and finally we will select from option here supports. Then save the project to the destination folder. Maybe save it as frame and save it. After that, we will type the project title, project name and date from project identification. Here we have title, date, project. We can write the title as analysis of plane frame and the project as frame and save it. After that, we will select Fnet data to generate the Fnet for drawing the frame. From this form or slab type form, we will select rectangular form, rectangular slab, sorry, with total length of 10 meter and total height or width 5 meter. And the next, the generation type, we will select the first type here as square with 1 meter interval in x and y direction. So we will have 10 intervals here and 5 intervals in y direction. Then finished it. Here we have the Fnet and save and close Fnet. After that, we will select girders to define girders material and draw the frame. First, we will select girder group, sorry, and select rectangular cross section. Then OK. Here is Young's modulus, height and width of beam. Young's modulus is 2 pi 10 power 7 and the height is 0.5, the width is 0.2. We will neglect the own weight of girders, then OK. And we will select add girders to draw the frame members or frame element. We'll start from here. We have a member with height 3 meter. Here we have group number if we have different type of beam element or frame element. We'll select it from here. And this problem we have only one type or uh, one element, one material, sorry. And start node and node, we will select OK, and then we will do other element. Here's the inclined member, and here we have uniform load with 5 meter. So we will draw this element as 5 meter only. Then we will draw other element here, and finally that's it. Yes. Save it, and we can change setting for drawing here. From setting we can select plot parameters, and Fnet we can unselect color girders or draw girder thickness, and save, close. Here we have only the frame member without thickness. Save it, and back to girders and close. After that we will define the loads. We have distributed load here for this inclined member and for this member or element. We will edit member to define uniform load. It will be self weight here. We have snow and wind. We will select self weight. It will be uh, 60 kilonewton. And for this inclined member, it will be 50 kilonewton. And we'll select node here from here to add concentrated load. We have here vertical load is 100, and at this point we have horizontal load minus 80 kilonewton. That's all load. We can change setting and maximum ordinate. Select uh, node arrow and change it to 30. We can change scale here, then save it. We can also change line format for the load. We can change color, change thickness here. Then save it and back to loads and close. After that we will select supports. To add supports, we have here fixed support. We will select nodes and select the node, then add supports from here. For fixed support we don't have displacement and X and Y direction. Also we don't have rotation here, so all of this will be 0. We have also here hinged support. We don't have displacement here, but we have rotation. And for this member it will be linked member, so we will edit hinges and double click for it and select hinges. I and J will be hinge node, then OK. and save and close it. After that, we will go to Solver tab here and select Computation of all. Finally, we will go to Result. We can draw results of data from n plane here. We can select system of loading, for example. We also have net numbering, coordinates in x and y direction, boundary condition, gather system. We have different elements. For example, system of loading. Here is it. We can change scale from scale here. Can change the scale of loads from setting. Select maximum coordinate and select maximum, enter for loads in plane. So maximum length for loads arrow, can change it here. We can also remove the ligand from here, from ligand, and unselect display ligand, save it and close. Here's the load. We can remove girder element type here from display values and unselect girder system, save and OK. To add supports to this figure, from back to graphic and select view grouping and select supports to draw support. Here is it. And back to results, we can draw results of supports action. We have here horizontal support or horizontal action, vertical action, moment. We can draw it here. Back to result, draw vertical action, and also we can draw moment action or show it. We can draw results for normal force, shear force, bending moment, and displacement, u and v, rotation, frame deformation. That's normal force here. Can also display or view shear force and bending moment. Also, we have frame deformation for all the frame. Here is it. Thanks.